Good morning, everybody. Is the
Good
slide
morning,
visible?
sir.
Good morning. Is the slide visible to
Good
you?
morning, sir.
Good morning, everybody. Okay, is the slide visible to you all? Okay,
Yes,
fine.
sir.
Can you just
Yes,
remind
sir.
me till how far we have completed? Anybody, can you please tell me how far we have completed in the last session? Yes?
So this was done and electric field due to a line charge also done.
Okay, fine. Thank you. So let us now move on to the next portion. So today we'll start with electric field of a charged conducting sphere. Okay. So in the last class we talked about how to make use this Gauss law in order to find the electric field at a particular point P, which is located away from a point charge. So over there, even though that method was not, it was the previous method that we followed by making use of Coulomb's law, there was not much difference in the calculation. So means there is, you people felt maybe you people have felt that application of Coulomb's law was equally easy and simple as that of your Gauss method. Next, we studied about the electric field, which to find an electric field due to a point located at a radial distance of x from the line charge. So over there, you could easily feel the essence of this Gauss law, how this Gauss law was proving to be a boon in order to simplify the calculations. Now the same thing, that same Gauss law, we will make use of that Gauss law in order to find the electric field due to a charged conducting sphere. Okay. Before that, let me tell you that here we will be dealing with two types of spheres. One is a charged conducting sphere, the other one is a charged isolated sphere. So basically, what I need to say is that this charged conducting sphere is nothing but a hollow sphere, and what you have done is that you have brought some charged body and you have touched this conducting sphere. Okay. So basically, what is the idea? The idea is that you are having a hollow sphere like this. Now, what you did is that you brought, let us say, charged iron rod. Okay. Let us say it is positively charged. Now, what you did is that you touched it to this charged conductor sphere. Okay. Now this sphere is made out of a conducting material. Now what will happen that this positive charge will now equally distribute itself along the circumference of the sphere. Okay. Now what we have to do is that we have to calculate that what is the electric field at any point P over here. Okay. Because of this conducting sphere. So what we did previously, there was a charged glass rod. We brought it close and touched this conducting sphere. Once we touch it, then the positive charges, this conducting sphere is going to be positively charged, and moreover, these positive charges are going to uniformly distribute themselves along the circumference of the conductor or the conducting sphere. So now what we are going to do is that we are going to evaluate what is the electric field due to a point P, which is located at some distance r from the center of the sphere. Okay, now let us try to follow the various steps. Now, over here it is written that this is a charged conducting sphere of radius capital R. Please note it is capital R. And it is carrying a charge Q, which is uniformly distributed on the circumference of the sphere as shown. Right? Now, please don't get confused that it is only residing in the inner portion or the inner circumference. No, that is not the case. It can also exist on the surface of this conducting sphere as well. Okay. So let us say this is the charge body and the charges are uniformly distributed along both the inner as well as the outer periphery of the surface, right? Now we are supposed to find the electric field. Now there are three possibilities and there are three positions where we need to evaluate the electric field. Okay, the first one is outside the sphere, and in this case, let us say I am having a point P over here, which is located at a distance of r, small r, from the conducting sphere, from the center of the conducting sphere. Now, please remember that this conducting sphere is itself having a radius of capital R. Now, obviously, since it is outside the sphere, naturally your R will be greater than R. So, we'll consider this to be case 1. Now, the case 2 says that we have to find the electric field inside the conductor. Okay. Next is on the surface of the sphere. Now again we have to find what is the electric field on the surface of this sphere. Okay, so there are three possible cases and each of them we have to individually work out to see. Now, the first case is field at a point P located outside the sphere. Okay, so as I told you, there is a particular procedure for the application of your Gauss law. So what we are first going to do is that, so this is your sphere. The next one is to identify where we need to find the electric field. So naturally, we are going to find the electric field at the point P over here. Now P is located at a distance of r from the center of the sphere. So how we are going to make the calculation? Just have a look. So the first thing is that we have to draw a Gaussian surface in such a way that it is symmetrically going to enclose the sphere completely. So for that we have to draw the Gaussian surface in such a way that the center of the Gaussian surface must be at the center of the sphere, right? So this is the first step. And the second step is that this sphere or the circumference of this closed surface, that is your Gaussian surface, must be passing through the point P where we want to evaluate the electric field. Now let us now apply our Gauss law in order to find the electric field. So our Gauss law says that the flux phi E is equal to Q enclosed by epsilon 0. Now who is enclosing this Q? It is nothing but the Gaussian surface which is enclosing the charge Q. Now obviously the charge Q is uniformly distributed, so that is a different thing. But the total charge that is enclosed by this is equal to the total charge Q on the sphere. No doubt the sphere Q charge Q is uniformly distributed, but if we are going to see what is the net charge that is enclosed by this Gaussian surface, then it is going to be capital Q. So obviously as per Gauss law, we know that phi E is equal to Q by epsilon 0. Now again from the generalized form of your flux equation, we know that phi E is equal to closed surface integral of E vector dot dA vector. Now obviously both of them are going to be the same thing. So Q by epsilon 0 is equal to closed surface integral of E vector dot dA vector. Now dA vector, if it is integrated over the entire surface, it is going to give a value of 4 pi r square. So E into 4 pi r square. From this, if we will do some little bit of mathematical manipulation, then we are going to see that your electric field E is equal to capital Q by 4 pi r square epsilon 0. Now obviously this is the magnitude part, but since your electric field is a vector quantity, so we need to express it in terms of a vector. So the direction vector over here is obviously going to be radially outwards. So naturally for that we have employed a r cap in order to justify that the electric field is going to be radially outwards, or the direction of the electric field will be along the direction of the radius. So for that we have written E vector is equal to Q by 4 pi r square epsilon 0 AR vector. Now, so this is how we have found out the electric field outside the sphere. Now everybody take out your pen and paper and just try to find out what should be the electric field inside the sphere. That means obviously I have solved it, but I want to see how much you people are understanding from the online classes. So here I am having the charge conductor. So the charges are uniformly distributed over here, right? And as I have told you that this is a hollow conducting sphere and it is having a radius of capital R. Now my question is that suppose I want to find the sorry, this is capital R. Now, my question is, suppose I want to find what is the electric field at the point P, okay? And this point P is located at a distance of small r from the center of the conducting sphere, right? Now, obviously, your r in this case is going to be less than the radius of the conducting sphere. Now, you have to evaluate what is the electric field at the point P. Okay. Now, let me tell you the procedure. As we all know that the first thing is that we have to draw a Gaussian surface, and in this case, the Gaussian surface is again going to be a sphere centered at the center of the conducting sphere. But the only thing is that it is going to pass through the point P, and this point P is going to have a distance of r from the center of the conducting sphere. Now, I am giving you 5 minutes of time, not 5 minutes, I am giving 3 minutes of time. Please try to evaluate it and tell me the answer. Is it okay for you all? Can you do it? I hope you people can do it. If you are having any doubt in this particular case, then you ask me, I will let you clear your doubt. But you have to solve the other problem that is inside the sphere. You have to find the electric field inside the sphere. Okay, please carry on. Let me see, or let me know.
Zero.
Yes, somebody is trying to speak out. Yes, okay. Please tell me. First, draw the Gaussian surface and then put the Gauss law. Yes, who will tell me?
Zero.
Yes, who is it? What is your name?
Sir, zero. Sir,
What is your name?
Ashutosh.
What is your name?
Ashutosh.
Asuka, very nice. You have answered it perfectly correct. So the answer is going to be zero. Okay. Now, is there anyone whose answer is not zero?
no,
Okay.
sir.
So, yes, somebody is trying to tell me something.
No, sir. I
Okay. So,
said the answer is zero.
yes, that's correct. So, what is your name?
Sir, Pranav.
Pranav, you are also absolutely correct. The answer is going to be zero. Now, is there anyone who can't understand why the answer is zero? Please let me know. Okay. Now, Pranav, you tell me why it is coming to be zero? Pranav, can you please justify why your answer is zero?
Sir, I don't
Yes.
remember properly, sir. I read it in the class 11th.
Okay, that's good. No problem. So, if you have remembered it, there is no problem. That is also a good way to learn. Okay, Asutosh, can you justify?
Because there is no charge inside the sphere.
Yes,
It is also
that is the right answer. Because okay, let me show you the idea. Now this is your conducting sphere. As I told you that this is hollow in nature. The charges are equally distributed along the inner as well as outer surface of this sphere. Now am interested to find the electric field at this point P inside the conductor. Now what I need to do is that I need to draw a Gaussian surface. So over here the Gaussian surface is again going to be a sphere, but and it should pass through the point P. Over here, as you can see, this radius of this sphere is small r. Now, when we are going to apply this equation, Gauss law, what are this Gauss law is telling us? It is saying that phi E is equal to Q by epsilon 0. Now, obviously, as I told you that this is a hollow sphere, so naturally the total charge which is enclosed by this Gaussian surface is going to be 0. Why? Because all the charges have equally distributed themselves on the outer periphery of the conducting sphere. So no charge is actually lying inside the sphere. Okay. So in this case, your Q enclosed is equal to 0. So Q, if it is equal to 0, then phi E is also equal to 0. So we can directly say that your electric field is going to be 0 inside a hollow conducting sphere. Okay, that's correct. So I'm very happy that you people have understood it. You have applied in the best possible way and you have got the right answer. Yes. Anyone else who is having any problem?
Yes.
Okay. If you are having any problem, don't worry. In the next slide, I have shown you the steps by which you are getting the electric field to be equated to 0. Okay. But before that, let us ask me another question. What will be the electric field on the surface of this conducting sphere? Yes. Who will tell me? Yes, come on. Tell me.
So Q by 4 pi R.
R? Q by 4 pi R. No, that's not correct.
Q by 4 pi R square epsilon.
No.
Okay. Which R? Small r or the capital R?
Where both are equal.
Yes,
Both
both are
side, both.
equal. So we can justify that on the surface of the sphere, your electric field is going to be the same as outside the sphere. So there is no difference. Because you see, in case of that outside the sphere, you are having this expression. So in this expression, if I will write that your capital R is equal to small r, then we can easily say that the electric field is going to be Q by 4 pi capital R square or 4 pi epsilon 0 capital R square AR cap. Okay. So AR cap is going to indicate the direction of the electric field, which in these cases is going to be radially outwards. So in the next slide, whatever I have explained over here, whatever answer you people have derived, that is written over here. Please have a look. Those who have not solved it, you please write it down for yourself. Please write it down. And over here, I'll give you explanation of this diagram. This particular diagram I have taken from the book. And this particular diagram is very interesting. And usually questions do come from this diagram as well. Now, as you people can see over here, let me explain you the diagram first. So you have the center over here. Okay. So at the center, the value of the radius is equal to 0. So on this x-axis, you are seeing at this point it is equal to 0. So from center to the position of the surface, okay, this entire distance is inside the hollow sphere. So inside the hollow sphere, obviously the electric field is 0. So you can see in violet color the marking is done that this is your electric field. So this is equal to 0, right? Now, at the point R, you are going to have your equation as Q by 4 pi epsilon 0 R square. So, this is the equation. So, it is at this point R on the surface of the sphere. Now, as you just have a look over here, as you move away from the surface of the sphere, this is coming as, or it is inversely proportional to r square. So inversely proportional to r square, therefore the graph is going to be a means parabolic like this. Okay. So as you keep on increasing the distance or as you keep on moving away from the center of the conducting sphere, the electric field is going to be drastically reduced and it is going to be reducing in a parabolic manner. So over here the graph looks like this. Okay. So ultimately we can say that from 0 to the edge of the conducting sphere it is 0 and afterwards it is going to behave in a parabolic manner or it is going to reduce in a parabolic manner, and as you move very away towards infinite then this value is also going to approach 0. Okay. So in this way we can say that your electric field at infinite is going to be almost equal to zero. So this is how we have solved it. Now, in the previous case, when we are talking about outside the conductor, we have shown the derivation. In case of inside the sphere, we have drawn a Gaussian surface, and as you can see, this is a hollow sphere. So all the charges are confined to the outer periphery of the circumference. Therefore, what is going to happen? The total charge which is enclosed by this Gaussian surface is going to be zero. So ultimately your phi E is going to be zero. So if this is going to be zero, no need of further calculation because obviously your E vector is going to be equal to zero. Now, next is the field at the point P. So over here, very simple, R is equal to, small r is equal to capital R. Just replace the small r by means of capital R as in the case of the outside the sphere. So over here, if you put it, you are going to get this expression. So in this way, we have justified this graph, and usually in the exam, this graph is a very favorite question of the teachers. They used to ask the explanation for this graph, or they used to ask for the derivation of all these things, and ultimately they will ask a question that please plot a relationship graph between the radius and the electric field of a conducting sphere. So please take into account the importance of this graph. Okay, let us now move on to the next case. That is electric field of a uniformly charged insulated solid sphere. So when I am talking about a solid sphere, what does it mean? That means the charge inside the sphere, it is not hollow. It is consisting of the same material throughout the entire volume of the sphere. And another important thing is written is insulated. What does this insulated means? Please note that suppose sometimes insulated, the word insulated is coming. Just imagine that if this one is touching the ground, can anybody tell me what is going to happen? Yes? Can anybody tell me if it is
The
touching
charge
the
will go to the
yes?
ground.
It is going to be grounded. Ground is always at zero potential, okay, or 0 volt. So naturally, when all this positively charged or negatively charged conductor touches the ground, then this one is also going to be neutral. So it is going to lose all its charges, and therefore it is no more going to have an electric field, or it is no more going to behave as a source of electric field. So please take into account that this is the charge, but it is insulated. That means in nowhere it is connected to the ground. Okay. So now let us try to evaluate, or let us try to see what is the expression for the electric field due to a uniformly charged insulated solid conductor. Similar to the previous case, here we will also be having three number of cases: one inside the sphere, the other one on the surface, and the third one outside the sphere. Just have a look over here. Now over here, even though the calculations look a little bit complex, but believe me, all of them are very easy to understand. Very, very easy. Okay. Now here, when we are talking about a solid sphere, now here we will introduce the concept of volume charge density. Okay. And volume charge density is usually denoted by the symbol rho subscript V. Okay. Now, what is this? This is okay. It is similar to that of lambda. That is your what? Line charge density. The total charge divided by the entire length of the line. Similarly, over here, in case of your let us say surface charge, we used to write it as sigma. Sigma is equal to total charge divided by the surface of the subject. Next, we have the volume charge density, and over here, your volume charge density is indicated by rho v. Okay, and rho v is nothing but equal to the total charge divided by the total volume of the sphere. And remember, in this case, the volume means it is absolutely solid. It is not hollow at all. Okay. So throughout the entire surface, so your plus signs are going to exist everywhere, not only on the surface, but throughout the entire body of the sphere. So like this, positive charges are going to be distributed equally throughout the entire volume. Okay, please take a note of the difference between a hollow sphere and a solid sphere. In case of hollow sphere, the charges are going to reside only in the outer periphery of the surface. Okay, whereas in case of uniformly charged insulated solid sphere, the charges are going to be equally distributed along the entire volume of the sphere. Okay, so I hope you have understood the concept of uniformly charged solid sphere. Now let us try to focus on how to find the expression of the electric field. Now over here, as you can see, rho V is equal to Q by V. So Q by V. What is V? V is nothing but the volume of the sphere with the radius of capital R. So naturally, we all know from mathematics that volume of a sphere is 4 by 3 pi R cube. Okay. Now, we are interested to find what is the charge enclosed by the Gaussian surface. Okay, because we know that the procedure is very simple. We have to apply two things. One is we have to apply the Gauss law, then we have to apply the expression of the flux, generalized expression for electric flux. Now, from these two equations, we can easily find out the electric field. But before that, we have to ascertain what is the value of this Q enclosed. Okay, so let us see how to find this Q enclosed. Now, since it is uniformly distributed, so Q enclosed is equal to rho B into the volume that is enclosed by this Gaussian surface. Okay, now, the Gaussian surface is the dotted line or the dotted sphere. Now, how much volume it is enclosing? Obviously, rho V into the volume of the Gaussian surface. Gaussian surface is a closed surface or a volume. So, for that, we will write rho V multiplied by 4 by 3 pi r cube. And please note, r is small over here, not capital. Okay. Now, we have already derived the expression for this rho V. So rho B is equal to capital Q by 4 pi 4 by 3 pi capital R cube. So let us replace this one over here. So if we will do that, then the expression comes out to be like this: Q by 4 by 3 pi capital R cube multiplied with 4 by 3 pi small r cube. So this 4 by 3 gets cancelled out, pi cancelled out. So finally, your Q enclosed comes out to be total charge Q whole into R by R cube. R numerator is small, denominator is capital. So if this is the case, now let us put all this thing in the first partial law of Gauss. So that is Q enclosed by epsilon 0. So in this case, it is going to be Q by epsilon 0, small r cube by capital R cube. So this part is over. Now let us concentrate on this part. So this part is nothing but the closed surface integral of E vector dot dA vector. So we will put it, the total, if we will integrate this total surface, closed surface area of the Gaussian surface, it is going to come as 4 pi r square. So 4 pi r square is equal to this much. So ultimately your Q comes out to be this much. Okay. And on the surface, very simple, we will replace this small r by means of capital R. So capital R and this r cube gets cancelled out and it results in this much. Okay. So I hope these calculations are very easy and everybody might have understood. Okay. If those who have not understood, please note it down over here. Whatever I have written, if you haven't understood, then please note it down. I am giving you some time. Please note it down. Maybe I will give you 3 minutes. Please note it down. These are very important expressions, and we need to learn about all these things. And moreover, you will get questions related to this. Maybe a derivation will come. Maybe it is possible that you will get some problems on these types of questions. So please draw the diagram like this. Please, I am giving you 3 to 4 minutes. Please do it fast. Then we will move on to the next slide. Please be online. I will be back within a couple of minutes. Please be online. Please don't leave the class. I'll just come in 2 minutes. Okay. So I hope everybody have noted it down. Is there any doubt? Anyone, any sort of doubt you have? Please have it clarified right now. Shall we move forward? Okay. No, I will not show you. Now you tell me, what will be the electric field outside the sphere? Yes? Do your own calculation and tell me the expression. Are you listening?
Yes, sir.
Okay. Can you do the calculation for the electric field at a point P which is located outside the sphere? Or in other words, the condition is R greater than R. Small r is greater than capital R. For that, you find the expression for the electric field. Now do it yourself. It is not at all a big deal. The one which was complicated, I have already done it. Now with all these basic ideas, you can easily solve for a point which is located outside the sphere. Now do it yourself. Now do it yourself. So right now it is 11:36. I hope by 11:38 you people can do it. Only 2 minutes time is sufficient. Yes, do it.
Sir,
Yes, tell me. I am here. So your
2
email
by 4,
is, yes, it is coming as
2 by 4 pi r square epsilon naught.
Q by 4 pi r square. Which r? Small r or capital R?
Small r.
small r square epsilon naught. Okay. So you are getting q by 4 pi small r square epsilon 0 a r cap. Okay, let us see what others are doing. Is there any other different answer from anybody? You can also tell me the wrong answer, but my objective is that you should keep working on a pen and paper. It should not be only one way, it should be both way. Don't be passive. Okay, let us see. Am I getting the same thing? Yes, I am getting the same thing. Thank you. Whoever had solved it, thank you very much. You have done it absolutely correctly. Okay. Now, please have a look at the relationship between R and the electric field. Okay. Now, as you can see in the first case, okay, this is, I am changing the value of this R, that is capital R, sorry, small r. Capital R is constant, that is the radius of the conducting sphere is always constant. Now over here you can see the electric field. Your electric field is directly proportional to R. Is directly proportional to R inside the sphere. So obviously if it is directly proportional, then obviously in this case you will see that the relationship is a straight line. So this violet color is a straight line like this. Okay, because over here your E vector is directly proportional to R. Okay, now when we are at a point on the surface of the sphere, your small r is equal to capital R. Okay, so if we put r over here, capital R equal to small r, this comes out to be r square. So at this point it becomes a constant. Okay, now since your surface is a point, okay, as we move away, then obviously this is also depicted as a point, right? Is there any problem in understanding it? Those who have not understood, actually this is absolutely very easy. Please don't think that this is complicated. It is very, very easy. Okay? So please, those who have not understood or you are getting some time to understand, please note it down. You may see it in during your free time, and you can see that how easy it is to find out. Next, the charge enclosed by the Gaussian surface. So the Gaussian surface is this one. So your Gaussian surface is this one. Okay. Now this is the insulated sphere, right? So this Gaussian surface is completely enclosing this sphere. So this sphere in total is carrying a charge Q. So obviously in this case Q enclosed is equal to capital Q. Now the Gauss law says phi E is equal to Q enclosed by epsilon 0. So you will get this much. Next, from the generalized expression of electric flux, we have this one is equal to Q by epsilon 0. Now, this one integrated over the entire closed surface of the sphere is equal to 4 pi r square. Okay. So, ultimately, E is equal to Q by 4 pi r square epsilon 0. So, in terms of vector, we can write E vector is equal to Q whole divided by 4 pi r square epsilon 0 a r cap, where a r cap indicates the direction of the electric field, and remember it is along the direction of the radius. Okay, so the radius in whichever direction you are going to do doesn't matter, it is always along the direction of the radius. Is there anyone who has not understood? Okay, there is nothing difficult about it, everybody can understood. And moreover, the calculation may looks a little bit complex, but believe me, if you know simple mathematics, then all these things are quite easy. Next, let us look on to the other part of the curve. Now over here, this is outside the sphere. So this portion is outside the sphere. So over here, E vector is inversely proportional to R square. Okay, so it is inversely proportional to 1 by R square. So naturally, this relationship is a parabolic relationship. So naturally, you will get a curve like a parabola. And as you move very away from the center of the conducting sphere, the electric field is going to drastically reduce, and as you move towards infinite, this value is going to be 0. Okay, so we can say that at infinite, all the electric field coming out of a positive charge is going to be 0. Okay, so everybody have understood, I hope. Is there any doubt, anybody? Please don't be shy. If you are even having any sort of silly doubt, no doubt it's silly for a teacher. It may be silly for your friends, but it is not silly for you, neither it is silly for the teacher. So you can easily ask without any hesitation. Okay, now let us move on to the problems. Okay, so these are your example problems. These are given in the book, but still then we are instructed to solve the problems before you. So we are going to do it now. So this is the first example. This is a very simple problem. Put the formula, get the answer type. Now just have a look at the problem. A disk of radius 0.1 meter. So here is the disk. Okay. So this disk is having a radius of 0.1 meter. Is oriented with its normal unit vector. Now I have told you that area is a vector quantity, and let us say this is the direction of your area, disk area, AN cap. Okay. So oriented with its normal unit vector AN cap at 30 degree to a uniform electric field. So this one is making an angle of 30 degree with respect to your E vector, that is your electric field. And moreover, this electric field is uniform. All right. Of magnitude 2 into 10 to the power 3 Newton per coulomb. See the figure. Okay. Now, since this isn't a closed surface, it has no inside or outside. That is why we have to specify the direction of A and cap in the figure. So if the direction is not given in the figure, you can assume it to be in any direction, doesn't matter. Now, first bit is what is the electric flux through the disk. What is second bit? What is the flux through the disk? If it is turned, so the A and cap is perpendicular to E vector. Now the other question is what is the flux through the disk if A and cap is parallel to E vector? Three simple cases. Okay. Now over here you can see I have given the given data because every time I have told you that whenever a problem is given to you, always write down what are the given data, what you need to find, and what is the appropriate or the most suitable expression or formula that you are going to make use of to solve the problem. Now, these things I am repeatedly telling you because all of these things do carry some mark. We are in our university, we always give stress because you people are undergoing ABET syllabus, and in ABET syllabus, there is some procedure provision to award you some mark for writing or picking the right data. So once you could understand what are the data given, that itself is going to award you some mark. Secondly, you have to write down if you don't know the answer or you don't know how to solve the problem, but at least you know or you can identify what are the given data, what are the formulas that should have been used to solve the problem, then also you are going to get appreciable mark. Maybe you will get around half the mark. So 50% of the mark will be awarded. So please don't neglect. Please follow the method that we people are asking you to follow. Now over here, you can see given data is E is equal to this much, R is equal to this much. So finally, we calculated the area to be this much. Okay. Now over here, every time whenever we are going to do such types of problem, previously I have always used a coordinate axis. I was telling you that we will draw a coordinate axis, then we will solve it. But in this case, I have not drawn any sort of coordinate axis. Okay. Can anybody tell me why I have not drawn any coordinate axes? Yes, when we are dealing with these types of problem in the past, I have always shown that your electric field will having a magnitude like this, and if direction is not given, then we will use the we will draw the coordinate axes and we will give some direction. But here I have not given any sort of direction. Can anybody tell me why I have not used the coordinate axis over here? Yes, is there anyone? Guesses? Okay, let me tell you. That since over here we are going to find the electric flux, and electric flux is a scalar quantity. So if it is a scalar quantity, why we will take the pain of putting the coordinate axes, expressing the E vector, A vector in terms of vector quantities? No need, because over here we are going to evaluate the electric flux, and that is absolutely a scalar quantity. And for scalar quantity, if magnitude is known to you, then nothing is a problem for solving it. So that is the reason why I have not expressed this electric field, this radius or this area in terms of vectors. I have not done it because ultimately we are going to solve for flux, which is itself a scalar quantity. Okay, now let us see the first bit. What is the electric flux through the disk? Simple question. So these are the electric field lines, and we are supposed to find what is the electric field. Now, obviously, this is a case of which case? I have given three cases. Case 1, case 2, case 3. Three cases I have shown you when we started this chapter. Just have a look over here. This is the first case, uniform electric field with area held perpendicular. Next, uniform electric field with area at an angle, non-uniform electric field. So I hope everybody have understood that all those stuff, and moreover they have already remembered it. Now the question is, which case this particular question is going to belong? Yes, yes, anyone? Come on, tell me. Okay, this is the case where your electric field and the unit area are held at an angle. Okay, so if that is the case, then the formula itself says that phi E is equal to modulus of E vector modulus of A vector cos theta, where theta is the angle between the unit vector of the area and the electric field. And over here, remember that here also you don't need to judge in which direction your theta is going to be oriented, whether it is from E to A or from A to E, doesn't matter, because this is a cos term. So if it is a cos term, then we don't need to take the pain of finding the orientation of the angle. Okay, so directly we have put the values, and ultimately we are going to get that it is 54 Newton meter square per coulomb. Similarly, next question. What is the flux through the disk if it is turned so that A n cap is perpendicular to E vector? What does this case means? So over here, these are the electric field lines. Okay. So we will have the disk like this, such that your A n cap, this is your A n cap. The question says that your A n cap is perpendicular to your E vector. Okay. Now, what is the theta in this case? Obviously, theta in this case is going to be 90 degrees, right? Okay, because theta is the angle between your E vector and your unit area vector, that is A n cap. So over here it is 90 degrees. So cos 90 degrees is 0, therefore the answer is 0. Obviously, even physically, if you will try to visualize this problem, you will see that the disk is lying parallel to the electric field, and therefore all the electric field lines will be tangential to it. No, none of the electric field lines are going to cross, or they are going to pass through it. They are simply tangentially passing through it. Okay, so this is the reason why it is going to be 0. So in either way, you can prove it. Last one is, what is the electric flux through the disk if A n cap is parallel to E vector? Okay, so this is your electric field, and I am having the disk like this, such that the angle means unit vector A n cap is parallel to your E vector. So in this case, it is asked to find what is the electric field. So very simple. You can say that it is E vector A vector cos 0 degree. Obviously, the angle between your A n cap and E vector is 0 degree. So ultimately, it results in 63 Newton meter square per coulomb. So this is a very simple problem. I hope everybody can do it. Next, next is a little bit means a lengthy problem, not at all a complex one. It is a lengthy problem. So the question says, what is the electric flux through a cube? Okay, so you are basically having a cube over here. Okay, now these are the electric field lines. So you have placed the cube inside this uniform electric field. Now it is simply asking what is the total electric flux through this cube. Can somebody tell me without going detail into this, what will be the electric flux? Yes, anybody? I hope we have done a problem like this, simple problem.
Zero.
Yes, absolutely. Very good. Why? Why? Please justify why it is zero.
Sir, because while entering into the phase,
Yes, you have understood it properly. Whatever flux is entering into it, that much amount of flux is coming out. It clearly shows that it is not enclosing any charge. Therefore, the total flux coming out of this entire cube is going to be zero. Okay. Now, here one important thing, let me tell you, even though it is not, it is beyond the scope of your syllabus, but here let me tell you a very interesting thing. Now, particularly when you are asserting how much flux is coming out or it is entering, what you have to do is that you have to see it in a whole, means you have to see it from the whole scenario you have to see. Now suppose let us say you are placing your eye just in front of this face, that is your given by N4 cap. Now, in that case, you will see only the flux lines are coming out. Similarly, if you will see it from the back side, that is in the area A1, you will say that all the flux are getting in. So in this case, if you try to judge the value of this electric flux, your answer will be wrong. So always remember that whenever you are going to find the electric flux coming out or moving in or whatever it may be, you have to see it from all the six sides. Suppose it is a cube or a cuboid, you have to see it from all the sides. Okay, particularly I am talking about cube and cuboid. You have to see from the electric flux from all the sides. Okay, so now let us solve this problem. So the question says an imaginary cubical surface of side L. So this is not a cuboid, it is a cube, and each of the side is having a length of L. Is in a region of uniform electric field E vector. Find the electric flux through each face of the cube and the total flux through the cube. When bit A, it is oriented with two of its faces perpendicular to E vector. Okay. So let us see. So what does that mean? That means suppose this is your first side. This suppose let us say this particular side given by N1 cap is side A1. Okay, or area A1. Now it is telling that this is the unit vector N1 cap. Okay, I'm just showing this particular phase, and it is saying that the electric fields are entering this cube from the side A1 or from the face A1 at 90 degree. Okay, so let us now find out what is the total electric flux. Okay, so first bit we will solve, then we will talk about the second bit. And the second bit, let us tell that this cube is slightly twisted. So if it is twisted by some angle, what is the electric flux? So we have to see in both the cases what are the flux which is coming out of this particular cube. Okay, now see how we have solved it. Now, if we have understood it, no need of means if it was a question in GATE exam, so nobody is going to solve this problem because time is very precious. If you have the fundamental very clear, one will say that obviously it will be zero. But for your level, you have to solve it step by step. Okay, so let us see. So over here it is written that figure A shows the unit vector n1 cap through n6. So n1 over here, n2 is over here in this direction, n3 is along this direction, n4 is along this direction, n5 top, n6 bottom. Okay, and this is as usual n1. Now n1 and n2 both will be anti-parallel to each other. Okay, each unit vector point outwards from the cube's closed surface. Obviously, this is going to be outwards. Can anybody tell me why it will be outwards? Why it is going to be outward? Yes, can anybody tell me why? I will not say that I will see it from inside the sphere, inside the cube. Why it should be outwards? Yes. Is it by coincidence or is it the rule or something like that? Okay, what I told, yes, somebody is trying to tell me something.
The rule.
Okay, now when before going deep into this problem, in the beginning I told you that we must see this particular scenario as a whole. Okay, not from any of the side. Okay, so if that is the case, obviously one needs to be outside the cube. Okay, one cannot be inside the cube. The person or the reference from where we are seeing or the entire scenario must be out. Okay, so if I am outside this sphere, so obviously all the electric field, all the unit vector of the areas will be outwards. Okay, that is the reason from the very beginning I have told you that you have to see this entire scenario as a whole. Okay, now if you are inside, you cannot actually justify because you will either see this face or this face. Okay, but as a whole, if you are over here, you can see actually what is the scenario, how the electric flux is entering, how it is coming out, from which side it is entering and from which side it is coming out. So please remember this. Okay, now let us try to solve the problem. Okay, so what we have written over here? So there are n1 up to n6 number of unit vectors, and each of these unit vectors of area are outwards, are having a direction outwards. Okay, the angle between, now let us see one by one. So let us first consider this A1, this area A1. Okay, so in area A1, your unit vector is in this direction, whereas your electric field is moving inside it. Okay, so where here, what will be the angle between them? It will be obviously 180 degrees because both are anti-parallel. So if that is the case, then E, that is your electric field magnitude, and A is how much? Since it is a cube with side L, it will be L square. So minus EL square. Now let us go for the other side, that is this side. So this is your N2 cap and this is the electric field, and you can see both of them are in the same direction. So obviously the angle between them is going to be 0. So that is what we have written over here. So it is EL cos theta is 0 degree. So this is EL square. Now what about the other faces? No need of much calculation because you can see the, for example, I will take this A5. This A5 is perpendicular to this E vector. Similarly, this N6 is perpendicular to this electric field. Similarly, this N5 and N6, they are also 90-degree apart from the electric field. So in all these cases, we can say the angle between them is 90 degree, and therefore the result will equal to 0. Now if you will make a total calculation, you will get this much. That is phi 1, phi 2, phi 3. If we will add, then we are going to get it as 0. Okay. So this is how my calculation will show. But if we have understood the general concept of Gauss law, then obviously directly we can say it is going to be 0. Now let us move. Okay, it's already time. I am sorry. I have already crossed 5 minutes. No problem. So the next part we will solve in the next class. So have a nice time. And please let me tell you one thing, because since there is shutdown, there is lockdown from Wednesday, I will be taking your classes from my residence. So there may be some problem because I will be using hotspot. So please cooperate with me. And till now, even after a repeated request to you all to send me a group mail, you have not given me. Otherwise, I would have given you the materials. Please do it fast. It is for your benefit. Okay. So have a nice time. Stay home. Stay safe. Thank you. Please be online. Let me take your screen, print screen. Please be online. Okay. Thank you.
Good afternoon, all of you.
Good afternoon.
Hope you are all doing well. So let me start our thing. What we have discussed on Saturday.
When we have just started static keyword.
We will start static keyword.
Static keyword. Okay. So we have already discussed the access specifiers. Okay, I am just brushing it up what we have discussed, and we are going to start with the static keyword. I have just given the introduction part. So first, let me share my screen first. Check it is visible to all of you.
Yes, ma'am.
Yes, ma'am.
Okay. So we have discussed already the access specifier. We have 4 types of access specifier: default, private, protected, and public. Protected, I have kept it for while we are discussing inheritance. We will discuss about the protected. Default keyword, here it will be providing access to the classes present in the same package, to the subclasses in the same package. While private, it will provide the access to whom? To the member instance variable and the method, okay, within the same class. So protected, we will discuss it later on. I am not discussing anything related to protected right now. Public. So if a class, method, or instance variable is declared as public, it can be accessible within the class within the same package, to the class in other package, and accessible by the subclass in the same package, accessible by the subclass in our other package. So the concept of subclass we are going to discuss right now after we completed the static keyword. Okay, now let's come to our static keyword. Static keyword, it is basically used for memory management with variable, method, blocks, and nested class. So write down another definition here. It is a variable, or if note it down, if a variable is declared as static, then that variable is the common property of all object, not unique for each object. Do you understand what is written here? Static variable. If a variable is declared as static, then that variable is the common property of all objects and it is not unique for each object. Are you getting this point?
Yes, ma'am.
Okay, the next point here is the static variable gets memory only once in the class area at the time of class loading. Okay, so the static variables get memory only once in the class area at the time of class loading. So it saves memory. It basically saves memory. So what does all these things means? So here I am giving you one example. Now you are your section is 204, I think 1009, isn't it?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
this one is your section 204 009. So if I am declaring a class as 009, so what are the properties of this class? ये class का क्या क्या property है? You people have your registration number. ठीक है. अच्छा, तुम लोगों का क्या है? You have some name. You have another property. The class will have the name. Then any other property?
Date of birth.
Date of
Ma'am,
birth.
strength.
नहीं, स्ट्रेंथ हर एक बच्चे का वही प्रॉपर्टी होना चाहिए ना. जितने भी तुम्हारे क्लास में द नंबर ऑफ मेंबर्स आर देयर, ऑल शुड हैव द सेम प्रॉपर्टी.
Yes, ma'am.
ओके. सो ने रजिस्ट्रेशन नंबर है, सबके पास रजिस्ट्रेशन नंबर है. नेम है, सबके पास नेम है. और क्या कॉमन है? और क्या है सबके पास? विच प्रॉपर्टीज आर कॉमन? अटेंडेंस, योर फोन नंबर, डेट ऑफ बर्थ. वन स्टूडेंट इज सेइंग डेट ऑफ बर्थ. ओके. एनी अदर प्रॉपर्टी?
Age group.
हाँ, एज ग्रुप. दिस आर ओके. डेट ऑफ बर्थ वही आ गया. और क्या हो सकता है? You all belongs to CSC branch?
Yes, ma'am.
Okay. You all belongs to CSC. So look here. No. नहीं. Then the college you are studying, यहाँ पर कौन से कॉलेज में पढ़ाई करते हो तुम लोग? String. Your college name here is? ITR. Okay. Now just I am just saying here you all have the. अच्छा, हर एक बच्चे का तो registration number same है क्या? You have the same registration number or you have different registration number? Last 3 digit या फिर 4 digit क्या है? सबका different है?
Yes, ma'am.
Okay. Similarly, name. All have the different name.
Yes, ma'am.
Name सबका different है. I think all will have the date of birth different date of birth है. लेकिन जो कॉलेज में पढ़ रहे हो वो कॉलेज सबके लिए क्या है?
Same.
सेम है.
Same.
So can I declare it as static?
Yes, ma'am.
Look,
Yes, ma'am.
these are ये सब तुम्हारे क्या है? All these are the which variable? These are the instance variable. Okay, these are the instance variable. If object A का अगर ये प्रॉपर्टी है, object B का भी प्रॉपर्टी क्या है? All having the same property. रजिस्ट्रेशन नंबर होगा, नेम होगा, उसके बाद तुम्हारा डेट ऑफ बर्थ है, तुम कौन से कॉलेज में पढ़ते हो वो है. ऑब्जेक्ट बी का भी रजिस्ट्रेशन नंबर, नेम, डेट ऑफ बर्थ, देन योर कॉलेज. नाउ लेट हियर वी आर हैविंग ऑब्जेक्ट सी. ऑब्जेक्ट सी का भी प्रॉपर्टीज क्या है? हैव सम रजिस्ट्रेशन नंबर, नेम, डेट ऑफ बर्थ एंड कॉलेज. तो यहाँ पर देखो, अगर यहाँ पर रजिस्ट्रेशन नंबर 1 होगा, here it may have 2, यहाँ पर रजिस्ट्रेशन नंबर 3 है. Similarly यहाँ पर A, this one is A, नेम हियर इज बी, यहाँ पर नेम सी है, डेट ऑफ बर्थ यहाँ पर सम XYZ. Similarly, here we have some date of birth. Again, here we are having some separate date of birth. But college सबका क्या है? What is the college name here?
ITER.
All are being the same college name. अच्छा, हर एक ऑब्जेक्ट में हम लोग अगर एक एक कॉलेज के लिए एक एक मेमोरी लोकेशन बनाएंगे, इज इट वो मेमोरी ज्यादा एक्स्ट्रा ऑक्यूपाई नहीं होगा?
ज़्यादा ऑक्यूपाई होगा।
हर एक ऑब्जेक्ट के लिए सब जो चीज कॉमन है उसको बार बार रिपीटेशन क्यों करेंगे? वो ज्यादा स्पेस नहीं लेगा?
यस मैम।
ओके, सो फॉर दैट वी आर एक वो जो क्लास एरिया है वहीं पर हम लोग एक ले लेंगे कॉलेज, वहां पर हम लोग सेट क्या कर देंगे? ITR. सो ये हो गया, ये क्लास एरिया में सेव हो गया. सो वी आर नॉट गोइंग टू प्रोवाइड योर कॉलेज. जब ऑब्जेक्ट A डॉट कॉलेज पूछा जाएगा वो किसको एक्सेस करेगा? ये मेमोरी लोकेशन को. ऑब्जेक्ट B डॉट ITR पूछा जाएगा, इट विल एक्सेस दिस लोकेशन. ऑब्जेक्ट C पूछा जाएगा तो वो कौन से लोकेशन को एक्सेस करेगा? कॉमन एरिया को एक्सेस करेगा. सो ये क्या करेगा? इट विल हेल्प यू टू सेव मेमोरी. सो सिमिलरली लुक, यू आर हैविंग कौन सा पेपर तुम लोगों का भी है? DSA. ओके, सो इन योर क्लास अगर हर एक DSA है, then another one you, I think you have your UPM paper is there and some other paper is there. कुछ अलग अलग पेपर है. मैथ्स है, कैलकुलस है. I think you have calculus, isn't it?
Yes, ma'am.
Okay. Now
Yes, ma'am.
suppose in your class, suppose let you have 20 or 30 students are there or 40 students are present. Now the papers are being allocated to you as DSA, UPM, calculus. If हर एक बच्चों का अलग अलग टीचर दिया जाएगा, is it possible to arrange individual teachers to each and every student?
No, ma'am.
So यहाँ पर क्या हो रहा है? Teachers, one common teacher is provided to the entire class.
Yes, ma'am.
पूरा क्लास क्या करे? वही टीचर को एक्सेस करते हो.
Yes, ma'am.
Okay, so now the teacher is belonging to your class. वो टीचर तुम्हारे क्लास को बिलोंग करते हैं ना? Does the teacher belongs to your class? Let take the example of mine. Okay, I am belongs to your class. I am taking what? DSA for your section 009.
Yes, ma'am.
Yes, ma'am.
But I am not part of your class. Okay, मैं तुम्हारे क्लास में पढ़ाती हूँ. Okay, I am not part of I am group linked to all the students of the class 009. मैं सारे स्टूडेंट को ग्रुप, पूरे स्टूडेंट्स को बिलोंग करती हूँ. I am not belonging to a individual student. किसी एक बच्चे को नहीं पढ़ा रही हूँ. I am not giving focus to a particular student. I am giving focus to all the students present in 009. So I am which member of your class?
Static member.
So I am the static member. Even though I am the part of the class, but I am the part of the class, but I am not directly associated with you. You all can access the common features that are being allocated to you. Okay, so the teachers that are being assigned to you are known as what? Static members of the class. So देखिए static member का example. Should we go with the example?
Ma'am, what is class loading?
Class? Yes, what you are saying?
Class loading.
हाँ मैं बता रही हूँ. क्लास लोडिंग मतलब तुम ये जो क्लास क्रिएट किए हो, यू हैव क्रिएटेड द क्लास, दिस क्लास. ये जो एग्जांपल मैं लिख रही हूँ यहाँ पर. अब जब ये मैं क्लास लोड कर रही हूँ, जब ऑब्जेक्ट क्रिएशन होगा तो ऑब्जेक्ट क्रिएट होगा तो तुम्हारा ये क्लास कॉल होता है. यू आर कॉलिंग द इंस्टेंस वेरिएबल एंड मेथड ऑफ द क्लास.
Yes, ma'am.
Okay, we have discussed that एक मेमोरी है, हीप मेमोरी है, एक नॉन हीप मेमोरी है.
Yes, ma'am.
ऑब्जेक्ट सब कहाँ पर क्रिएट होता है? हीप मेमोरी में सारा ऑब्जेक्ट क्रिएट होगा.
Yes, ma'am.
ओके, नॉन हीप मेमोरी में तुम्हारा क्या रहता है? जो मेथड्स रहता है उसको नॉन हीप में रहता है.
Yes,
Yes, ma'am.
Okay, similarly जब भी ये क्लास तुम्हारा लोड होता है एक स्टैटिक मेमोरी बन जाएगा. देयर विल बी वन स्टैटिक मेमोरी. वो मेमोरी लोकेशन का नाम क्या होगा?
College.
द नेम ऑफ द मेमोरी लोकेशन विल बी कॉलेज और यहाँ पर वैल्यू क्या होगा? ITR. तो इवन दो तुम जितने सारे भी ऑब्जेक्ट बनाओगे ये मेमोरी लोकेशन में कुछ चेंजेस नहीं होंगे. देयर विल बी नो चेंज इन दिस मेमोरी लोकेशन. ये फिक्स्ड ही रहेगा. Okay, I am just showing you the example, then you will get the idea. Okay, should I go to the
non-heap memory.
हाँ,
It will be non-heap memory.
हाँ, it is the non-heap memory. तुम्हारा ऑब्जेक्ट जहाँ पर है वो वहां पर नहीं रहेगा. It will be in the class area. जहाँ पर तुम्हारे मेथड्स रहते हैं नॉन हिप मेमोरी में वहीं पर रहेगा. So that part will be fixed. Okay. I am just showing you one example. You will be get clear on it. Should I move to the example part?
Yes, ma'am.
हीप मेमोरी में वो नहीं रहेगा. वो नॉन हीप एरिया में जाएगा जिसे हम लोग क्लास एरिया भी बोल सकते हैं. Just I'm just moving to the example part. You will get the idea. The static example. No error. So INT registration number. Here we will have string name. There will be another variable string college equals to IPE the student INT registration number name string name. यहाँ पर आ गया तुम्हारा string college. Here void display. System.out.println. यहाँ पे प्रिंट क्या क्या होगा? It will print your name, then your
Registration number.
और क्या रह गया? Registration number, then
College.
in main function, I will show you the memory allocation. In the main function, here the object is being created for the student class. Student S1 is equals to new student. Then here 1 पहले क्या है registration number, the name here is let it be AA, then college IIER, and I will put a semicolon. Again another student, it is being created, student S2 is equals to new student, this one is 2, this one is AB, this one is IIER. This one dot display S2 dot, ये देखो. So when I am going to click here, यहाँ पर देखो तो क्या क्या आ रहा है. When I am creating the object S2 dot, यहाँ पर क्या आ रहा है? College name and registration number. Here display method it is being showing. So here I am putting the display. So तीनों instance variables show कर रहा है.
Yes, ma'am.
Name, registration number, college. So for each object में तुम्हारा कितना memory location create हो रहा है? How many spaces are being created for each object?
3.
3. एक name के लिए, एक registration number के लिए और एक college के लिए. ओके 3 स्पेस हो रहा है, लेकिन तुम्हारा जो कॉलेज का नाम है यहाँ पर क्या हो रहा है? इन द बोथ द केसेस कॉलेज नेम इज ITR. दोनों केसेस में सेम है. सो ऑल द स्टूडेंट लेट इन योर कॉलेज student. What happened? We already defined है. Okay. Okay. Now in your यहाँ पर क्या हो रहा है? देखो name and registration number both are different, but the college name यहाँ पर क्या है? Same है. तो अगर एक ऑब्जेक्ट में कितना मेमोरी स्पेस क्रिएट हो रहा है? 3 spaces are being created in order to store name, registration number and college. So if I will declare it as static, अगर मैं इसको static declare करूँगी, so now check the difference. If I am going to declare it as static, so we don't need to provide the college name every time. College name हमें every time देने की कोई जरूरत ही नहीं है. We don't need to write it. Look, यहाँ पर कुछ एरर आ रहा है अभी देखो तो.
No, ma'am.
Does at the time of object creation it is showing any kind of error?
No, ma'am.
Okay. Now हाँ अभी देखो मैं प्रोग्राम रन करती हूँ. Now I will run the code. What is it is showing?
AA1 ITR, AB2 ITR.
AA1 and ITR, लेकिन ITR हम लोग कहीं पर भी इनपुट किए हैं.
No, ma'am.
So ये स्टैटिक है, मतलब ये क्या है? ये फिक्स्ड हो गया. Okay, this one is a common for all the objects. सारे ऑब्जेक्ट के लिए ये क्या हो गया?
Common.
कॉमन हो गया. तो सारा ऑब्जेक्ट अब यहाँ पर जब डिस्प्ले फंक्शन कॉल हो रहा है, वो कॉलेज को क्या ले रहा है? डायरेक्टली वही कॉमन लोकेशन से ले रहा है.
Yes, ma'am.
ओके इफ आई विल नॉट पुट इट स्टैटिक, अगर मैं इसको स्टैटिक नहीं लूंगी, देन देखो क्या आ रहा है. व्हाट विल बी द आउटपुट? चेक इट.
ITR.
जस्ट अ मिनट.
Ma'am, you have initialized the college. That's why.
हाँ, that is why it is showing. Now I want to show you the difference. How to show it? Common area. I want to show you the difference between the common area. Okay. That is what I am thinking. How to show it you. One is asking na how what is class area. क्लास एरिया कोई पूछा है ना? ओके लेट पे कॉलेज. यहाँ पर देखो, यहाँ पर मैं कॉल क्या करूंगी? कॉलेज. आई वांट टू कॉल इट एज okay. I will show you another example, Nico. Let here put it as static. There. Should I go with another example to show the common memory location?
Yes, ma'am.
यहाँ पर पता नहीं चलेगा because here it is already been defined. You will not find the difference here. I am just doing another example. All of you note down this example first. Then I will show you how the college area वो वाला example दिखा दूँगे by taking some integer value. Note it down for this one. Have you noted it down?
1 minute.
Writing.
Note it down. I will show you another example. लिख लो ये वाला पहले. यहाँ पर आ जा रहा है because here if I even though I will not provide you static here, यहाँ पर ITR आ जा रहा है as the college name is initialized as ITR. यहाँ पर initialize हो गया है and for each object it is showing as your each object space में क्या create हो जा रहा है, वो college के लिए create होके ITR show कर रहा है but it is not showing the common area. Okay, वो common area में access नहीं कर रहा है. I will show you another example. Have you completed this one?
Yes, ma'am.
Okay. So another example, let here I will take another class. Let the class name here is count. Okay. INTC. यहाँ पर मैं 0 set कर दी. Now here a constructor here I will take count. Now I will update the println. In the method यहाँ पर count a equals to new count method call कर दी. Sorry, I created the object count b equals to new count, then count c is equals to और c नहीं confusion हो जाएगा, d is equals to new count. Now check here. I will run this code. यहाँ पर क्या आउटपुट आ गया?
111.
111. Now suppose here I will take the variable as static. Now check what you are getting.
1, 2, 3.
1, 2, 3. तो अभी डिफरेंस पता चल रहा है how it is happening. In the previous case count क्या हो रहा था? C.
Yes, ma'am.
In the previous case C क्या हो रहा था? If I am not using the keyword static, if keyword static use नहीं हो रहा है, then C क्या हो गया? It is the variable of
Object.
every object के लिए क्या हो रहा है? अलग अलग से अपडेट हो रहा है.
Yes, ma'am.
Okay, if I am declaring it as static, यहाँ पर अगर मैं static declare करती हूँ, तो ये कहाँ पर store हो रहा है? where you are accessing it.
Class area.
क्लास एरिया मतलब एक ही कॉमन मेमोरी में रहेगा, दैट इज नॉन हीप मेमोरी में रहेगा. ओके, एंड ऑल द ऑब्जेक्ट्स आर एक्सेसिंग टू दैट, to this variable, and the variable it is updating to 1, 2 and 3. Okay, are you getting my point?
Yes, ma'am.
Yes, ma'am.
Okay, note down this example also. It is your last year question is there also. Output based question में ये question भी था. Okay, note down this question also. So what is the difference between the static and the non-static variable? Okay, note it down. पहला केस का भी आउटपुट लिख लो, and if you are not declaring it static, then what is the output? You just note it down. If you are declaring it as static, then what is the output? You note it down. Okay, if I will put here a static, what is the changes here you are encountering? Just note it down. Okay. So here I am writing in the comment line, static variable, important point है, static variable will get the memory only once if any object changes the value of the static variable it will retain its value. Okay.
हम थोड़ा राइट साइड में जाइए पीछे.
हाँ, just a minute. I'm just a minute. दिखा अभी?
Yes, ma'am.
Okay, note this point and mark it also important. Static variable will get the memory only once. If any object changes the value of the static variable, it will be retain its value. Okay, and write down the output also, what you are getting here. Over?
मैम नहीं थोड़ा एक
हाँ, लिखो लिखो.
Ma'am, at the last it is written it will retain its value.
हाँ, it will.
Change its value.
And if any object changes the value of the static variable, it will retain its value. अगर static variable का value change होता है, यहाँ पर क्या हो रहा है? Change हो रहा है?
Yes, ma'am.
Okay, so वो जो value है, पहला का जो value है, वो वही रहेगा. Value में कुछ changes नहीं होगा. यहाँ पर कितने ऑब्जेक्ट तुमने क्रिएट किया है?
3 objects.
3 ऑब्जेक्ट. तो इनिशियली वैल्यू क्या था? 0 था. तो ऑब्जेक्ट यहाँ पर क्या कर रहा है? वैल्यू चेंज करने की कोशिश कर रहा है। जब भी तुम एक ऑब्जेक्ट बना रहे हो, या यहाँ पर वैल्यू क्या हो रहा है, अपडेट हो रहा है।
Yes, ma'am.
तो पहला में जो 0 था वो कितना अपडेट हो गया, 0 से
1.
1 बन गया। अब दूसरे बार जब ऑब्जेक्ट क्रिएट हो रहा है, अगेन क्या हो रहा है, वैल्यू चेंज हो रहा है।
Yes, ma'am.
तो ये जो पहला वैल्यू कितना था, 1 था, 1 चेंज हुआ क्या तुम्हारा 0 को? इन दिस ऑब्जेक्ट कॉल 0 से कितना चेंज हो गया तुम्हारा,
1.
1। यहाँ पर 1 से 0 चेंज हो रहा है क्या? इज इट चेंजिंग फ्रॉम 1 to 0?
No, ma'am.
चेंज नहीं हो रहा है। यहाँ पर क्या हो रहा है, 1 से कितना हो रहा है,
2.
इट इज नॉट चेंजिंग। तो वो जो भी पहला का वैल्यू था वही रह रहा है कि नहीं रह रहा है?
Yes, ma'am.
Okay, so it is saying that if any object changes the value of the variable, it will retain its previous value. But for your better understanding, write it down. मैं यहाँ पर previous लिख देती हूँ. Okay? तो previous value है वही रहेगा, तुम उसी के ऊपर अपडेट करोगे. Are you getting my point?
Yes, ma'am.
बन गया सबका?
Yes, ma'am.
Okay, if I am not declaring it as static, तो क्या हो रहा है, ऑब्जेक्ट अपडेट होते ही जो प्रीवियस वैल्यू क्या हो जा रहा है, वो रीसेट होके कितना बन रहा है,
0.
एवरी टाइम 0 हो जा रहा है। तो यहाँ पर आउटपुट कितना आ गया, एवरी ऑब्जेक्ट के लिए एवरी टाइम इट इज रीसेटिंग, सो आउटपुट हियर इज 1 1 1। बट इफ यू आर डिक्लेयरिंग इट एज स्टैटिक, जो वैल्यू था वही रहेगा, उसे तुम चेंज नहीं कर सकते हो, यू आर जस्ट इंक्रीमेंटिंग द वैल्यू। यू आर गेटिंग द डिफरेंस?
Yes, ma'am. मैम
हाँ बोलो।
मैम एक और बार मैम क्लास लोडिंग को समझा दीजिए।
क्लास लोडिंग वही है, ये यहाँ पर मैं अभी क्या कर रही हूँ, व्हाट आई एम डूइंग हियर, ये क्या हो रहा है, ये जो ग्रीन बटन प्रेस कर रही हूँ ये क्या हो रहा है, बताओ। ये मैं प्रोग्राम रन कर रहा है। जब हम लोग प्रोग्राम को कंपाइल करते हैं, ये क्या है, क्लास काउंट है।
यस मैम।
ठीक है, तुम्हारा जेवीएम में मेमोरी है, अपना मेमोरी लोकेशन है।
यस मैम।
जेवीएम में जो मेमोरी लोकेशन है, दो तरीके के मेमोरी लोकेशन है। एक हीप मेमोरी है, जहां पर क्या स्टोर होगा, जो भी ऑब्जेक्ट बनाओगे वो कहां पर स्टोर होगा,
हीप मेमोरी।
हीप मेमोरी में स्टोर होगा। ठीक है,
यस मैम।
ओके। और एक मेमोरी है जो हीप एरिया में नहीं जाता है, उसे हम लोग क्या बोलते हैं,
नॉन हीप मेमोरी।
नॉन हीप मेमोरी। नॉन हीप मेमोरी में क्या क्या स्टोर होते हैं, ये क्लास का, ये देखो ये क्लास है, ये क्लास का मेथड क्या है, ये एक मेथड है।
यस मैम।
ये मेमोरी ये कहां पर स्टोर होगा, नॉन हीप मेमोरी में स्टोर होगा। ये मेथड को कौन एक्सेस करेगा, ये दोनों ऑब्जेक्ट क्या करते हैं, ये मेथड को एक्सेस करते हैं।
यस मैम।
ये मेथड का कोड सिमिलरली जो नॉन हीप मेमोरी है वहां पर क्या स्टोर होगा, स्टैटिक वैल्यू स्टोर होगा। तो अगर वो स्टैटिक वैल्यू स्टोर होगा, अब इसको कौन कौन एक्सेस करेगा, जो भी ऑब्जेक्ट बनेगा क्लास का।
यस मैम।
ठीक है, ये कब होगा, ये सब जो मेमोरी स्टोरेज सब कब होगा, जब तुम लोग प्रोग्राम को क्या करोगे,
रन करोगे।
रन करोगे। तो एट द टाइम वो क्लास को क्या बोलते हैं हम लोग, उसको क्या बोलते हैं, द क्लास इज
लोडिंग।
लोडिंग। जब मेमोरी में मेमोरी क्रिएशन होता है, जो ऑब्जेक्ट एक्सेस करता है, दैट प्रोसेस इज नोन एज मेमोरी लोडिंग। कभी कभी देखते हो ना, यहाँ पर एरर आ जाता है रन टाइम में, द क्लास इज नॉट लोडिंग।
यस मैम।
ओके, आर यू गेटिंग?
यस मैम।
शुड आई मूव टू द नेक्स्ट पार्ट?
यस मैम।
यस मैम।
So here the next part here is, remember the point, static method. Why we need a static method? Variable static होगा तो क्या होगा पता चल गया. Next, write down static method that we have already done in the last semester. But here we will understand the concept of static method. So static method क्या है? A static method belongs to the class rather than the object of the class. Static method can be invoked without the need for creating an instance of the class. Next, static method can access static data member and can change the value of it. Okay, so what is a static method? ये जो static variable declare करते हो उसको कौन access कर सकता है, उसका value को कौन change करेगा? That will be changed by the static method. Non-static method वो value को change नहीं कर सकते हैं. Okay, and another thing, teaching. In your class, teaching क्या है? Teaching, it is a process that belongs to the entire class. Does it belongs to individual student?
No, ma'am.
So मैं बस एक को पढ़ा के क्लास से बाहर आ जाऊंगी, सबको नहीं पढ़ाऊंगी, चलेगा?
No, ma'am.
So static method, it belongs to the entire class, not to an individual object. Okay, similarly, static method, it can be invoked without the need of creating the instance. तो लास्ट टाइम जब भी मेथड क्रिएट करते थे तुम लोग ऑब्जेक्ट बना के कॉल करते थे क्या मेथड को?
No, ma'am.
तो हम लोग बस सिंपली कॉल करते थे. तो वो और एक एडवांटेज है. स्टैटिक मेथड के लिए हमें ऑब्जेक्ट नहीं चाहिए. स्टैटिक मेथड दूसरा, दिस इज द मोस्ट इंपॉर्टेंट वर्क ऑफ स्टैटिक मेथड. इट इज यूज्ड टू चेंज द और एक्सेस द स्टैटिक डेटा मेंबर. स्टैटिक डेटा मेंबर का वैल्यू ही चेंज कर सकता है कौन? स्टैटिक मेथड. सो हियर आई विल शो यू द एग्जांपल. यहाँ पर कॉलेज का नाम क्या है?
ITR.
ITR है. नाउ हियर आई विल यूज अ मेथड. यहाँ पर मैं डिस्प्ले मेथड. डिस्प्ले कौन सा मेथड है? स्टैटिक है या नॉन स्टैटिक है?
Non-static method.
नॉन स्टैटिक मेथड है. नाउ हियर लेट आई विल चेंज टेक अनदर नॉन स्टैटिक मेथड चेंज. अब ये नॉन स्टैटिक मेथड में मैं क्या करूंगी, वो नाम को चेंज करूंगी. आई वांट टू चेंज द नेम. ऑल इज इक्वल्स टू, यहाँ पर मैं लिख देती हूँ, लेट हियर आई एम राइटिंग SOA.
मैम चेंज के बाद वो ब्रैकेट्स.
हाँ हाँ, एक मिनट. यहाँ पर कॉलेज का स्पेलिंग गलत हो गया है. तो सब हो जा रहा है चेंजेस. हाँ, ओके, देखो व्हाट इज द आउटपुट हियर. यहाँ पर आउटपुट क्या आया? तो यहाँ पर मैं क्या की थी? हियर आई हैव चेंज द वैल्यू. डज इट चेंजेस?
No, ma'am.
कॉल भी ना किए हम लोग.
यहाँ पर मैं चेंज कर रही हूँ. डज इट चेंजिंग द वैल्यू ऑफ कॉलेज? हाँ बोलो.
ना हम लोग उस मेथड को कॉल नहीं ना किए हैं तो चेंज कैसे करेगा?
ओह सॉरी सॉरी. Very good. H2 dot display S1 dot change hand. What else? That is the problem. A. Okay, it is changing the value of the static method. Okay, यहाँ पर हो रहा है. You try with your सबका यही JDK installed है ना? JDK 11.
Yes, ma'am.
Yes, ma'am.
Okay, there are the changes. It will not show you here. Okay. So basically, static methods are used to change the variables data members of the static variable. Okay. And another thing, we don't need the instance of the class to अब यहाँ पर ले रहा है. It is taking everything. Okay. And यहाँ पर we don't need the instance of the class in order to call static method, but this version of Java, it is accepting everything. Okay. Static method change, it should be accessed in a static way. बस warning दिखा रहा है, but it is working. Once it is the method of this class. Just a minute, I am doing another example. Okay, anyways, it is showing the changes here. I am unable to show you the changes here. Okay, यहाँ पर ये method का नाम क्या है? What is the void change? यहाँ पर मैं declare क्या की हूँ? Static. And here we don't need the object in order to call the method. बस यहाँ पर एक warning देके रह जा रहा है. We don't need the instance to call the method. Okay, we can directly call the method, and the वो जो दूसरा point है, it is not working here for this case, as I have a higher version of JDK. Okay, so static method, ये दोनों point याद रखो. You just remember this method point. Static method can access the static data member and can change the value of it. Okay.
Yes, ma'am.
Okay, this is working in the higher version of Java, but in the older version it is not working. Okay, ये जो static members हैं, it will be only accessible through static method. यहाँ पे error नहीं दिखा रहा है. It is not showing any error. You just remember this point. Okay, should I move to the next part? There is another one is there, abstract class. You just remember this 3 points. The use of the static method. Okay. Anyone is saying something? Next, another keywords are there, abstract and then there is another keyword, abstract. I will discuss it after we will discuss inheritance. And final, I think we have already discussed the final keyword. Final वाला हम लोग पढ़े हैं.
Scroll a little up, ma'am.
फाइनल क्यों यूज होता है?
किसी वेरिएबल को कांस्टेंट
हाँ, किसी वेरिएबल को कांस्टेंट डिक्लेयर करने के लिए. Okay, we are using the final. So next we will start inheritance. Next one is inheritance. Abstract वो मैं बताऊंगी जब we will do polymorphism concept.
मैम
हाँ बोलो.
मैम हम लोग फाइनल कीवर्ड जो है मेथड्स के साथ यूज कर सकते हैं.
मेथड के साथ, हाँ मेथड के साथ भी यूज हो सकता है फाइनल कीवर्ड तो.
यस मैम.
हाँ, you can use it. अब यहाँ पर क्या आ गया? Cannot make a static reference to a non-static. आ गया?
मैम तो इसका यूज क्या होगा फाइनल का?
इसका फाइनल का तुम्हें क्या है? कांस्टेंट क्रिएट करोगे. बेसिकली वी आर यूजिंग फाइनल टू क्रिएट द कांस्टेंट.
मैम मेथड में फाइनल कीवर्ड का यूज करने का क्या मतलब है?
क्या हुआ मेथड में? जस्ट अ मिनट. It's working. Everything is working here. This one down. मेथड में कुछ काम नहीं है. बट वी आर बेसिकली यूज टू, यहाँ पर चेंज हो गया एबीसी को. जस्ट अ मिनट. Someone is saying something. Just a minute. Hold on. फाइनल को तुम लोग मेथड में यूज कर सकते हो, बट द changes you will not find here. I think you will find in the concept of inheritance. Okay. Final का काम क्या है? What is the use of final?
To make the variable constant.
To make the variable constant. लेकिन यहाँ पर क्या हो रहा है? You are not finding any changes here. Okay, if you are defining a method as final, you are not finding any changes here. But when we are using the concept of inheritance में final का काम क्या है पता चलेगा. Okay, two keywords are there. One is abstract and another one is final. Abstract and final use will be when we are using the concept of polymorphism, and this one when we are using the concept of inheritance. In the what you call that one is your method overriding.
मैम थोड़ा सा ऊपर स्क्रॉल कर दीजिए.
क्या हुआ?
ऊपर स्क्रॉल कर दीजिए ना, लिखना था.
अच्छा लिखो, जल्दी जल्दी लिखो. I will start inheritance. This part.
Yes, ma'am.
जल्दी कंप्लीट करो. I will start inheritance. So what do you mean by inheritance? Anyone?
Inheriting the property of some other class.
Inheriting the properties of some other class is known as your inheritance. Okay, how many types of inheritance are there? Anyone having any idea? How many types of inheritance are there?
Six.
Inheritance. Six. What are they?
Which type of
Yes.
single inheritance,
Then
multi-level inheritance,
multi-level inheritance. Next,
hybrid inheritance,
hybrid. Then
heretical inheritance.
hierarchical inheritance. Then
Ma'am, I know about this much.
this much. Anyone having any other idea? ये तो चार हो गया.
Multiple inheritance,
Just a minute. Hierarchical. Then multiple.
multiple. Yes, ma'am.
Then एक दो तीन चार पांच हो गया. और कुछ है? मल्टी मल्टीपाथ फिर क्या है?
Ma'am, we have only 5, no?
So we are single, multi-level, hybrid, hierarchical, multiple inheritance. There are 5 inheritance, but we will discuss here how many inheritance? How many inheritance? Single, multi-level, hybrid, and hierarchical. Does multiple inheritance is a वो जो concept है यहाँ पर ambiguity नहीं आता है? Does you don't find any ambiguity in multiple inheritance? You learn multiple inheritance कहाँ पर पढ़े हो?
Oops concept.
Oops concept. In your C++, I think you have learned multiple inheritance, isn't it?
Yes, ma'am.
Okay. So multiple inheritance, we have ambiguity. So in order to overcome that ambiguity, we are moving to multi. We are not using multiple inheritance in Java.
Excuse me, ma'am.
हाँ बोलो.
मैम मल्टीपाथ इनहेरिटेंस वो क्या होता है मैम?
वो कुछ नहीं होता है. We have only this much. Single, multi-level, hierarchical, hybrid, and multiple.
Okay, multipath is only multiple.
Multiple inheritance is not there in Java. In order to achieve multiple inheritance, we will learn interface. Okay, there are some ambiguity in multiple inheritance. So it is basically not used in Java. Instead of multiple inheritance, we will learn what?
Interface.
Interface. The basic 3 types of inheritance we are going to discuss, that is single, multi-level, and hierarchical inheritance. Okay, and hybrid. Hybrid is what? Hybrid, it is a combination of either single or multi-level, or a multi-level or hierarchical inheritance.
Okay, ma'am.
So we are going to discuss.
एम्बिग्यूटी क्या है मैम?
एम्बिग्यूटी क्या है बताऊंगी. मल्टी लेवल में क्या होता है? मल्टीपल में 2 क्लास एक को इनहेरिट करते हैं. आई थिंक
मैम
Is this the
एक क्लास, यस, एक क्लास 2 को
एक क्लास 2 को इनहेरिट करता है. तो एक क्लास ये मल्टीपल है तुम्हारा. सोच के बताना which one is multiple inheritance. So when a class is being inherited by a number of classes, तो ये क्लास का प्रॉपर्टीज क्या होता है? What is happening here? The properties of the class is present here and here.
Yes.
Then again तुम लोग क्या करते हो? You are deriving another class.
Yes.
हाइब्रिड में ये कंसेप्ट यूज होता है ना? अनदर ये दो क्लास से और एक क्लास को डिराइव करते हो. Then what is happening? ये क्लास का प्रॉपर्टी यहाँ पर कितने बार आता है? How many number of times a property of this class is coming to the last class? 2 times. So this is this is known as your ambiguity, and in order to avoid this ambiguity we are using the concept of interface. So we will discuss in detail in the next class what are the different type of inheritance and how we are going to use the super keyword in the concept of inheritance. Okay, for today's class this much. Thank you all.
Thank you, ma'am.
And also ये जो final keyword in method overriding we will use the concept of final keyword. Thank you all.
Thank you.
Thank you, ma'am.